In the world of Java programming, where precision and efficiency are key, exceptions are unforeseen events that disrupt the smooth execution of your code. They can be as simple as a typo or as complex as a network failure.
Imagine a program trying to divide a number by 0. This is a classic example of an exception. This operation is mathematically impossible and will cause an error. This would lead to a runtime error, halting your program abruptly and potentially causing data loss.
Exceptions can arise from various sources, including user input errors, such as accessing an array element that doesn't exist or encountering network issues. Even hardware failures can trigger exceptions. When an exception occurs, Java creates an object that represents the error condition, providing detailed information about what went wrong.
If exceptions are not handled properly, they can lead to program crashes and unexpected behavior, making your application unreliable. This can be disastrous, especially in critical systems where stability is paramount.
This is where the art of error handling comes in, allowing developers to anticipate and manage potential issues. Using try-catch blocks to handle exceptions effectively ensures that your program can recover gracefully from errors and continue running smoothly. The try-catch mechanism in Java is like a safety net for your code, allowing you to catch and handle exceptions gracefully.
For example, let's look at this code snippet. Try int result equals sign 10/0 / this will throw an arithmetic exception. Catch arithmetic exception e systemout.println error division by 0.
The catch block specifically catches arithmetic exception and handles it by displaying an error message. Java allows you to handle different types of exceptions separately using multiple catch blocks.
Take a look at this example try / code that might throw exceptions. Catch arithmetic exception e / handle arithmetic exception. Catch ArrayIndexOutOfBoundsException e / handle ArrayIndexOutOfBoundsException. Catch exception e / handle any other exception.
The order of catch blocks matters. The last catch block uses the generic exception type, which acts as a catch-all for any other exceptions. A common use case for the finally block is to close resources like file streams or database connections. This ensures that no matter what happens in the try or catch blocks, these resources are properly released, preventing potential memory leaks or other issues. For example, try / code that might throw an exception. Catch exception e / handle the exception. Finally / code to be executed always. This structure guarantees that the finally block will run even if an exception is thrown and caught. The code within the finally block is always executed, providing a way to clean up resources or perform final actions. This is particularly useful in scenarios where you need to ensure that certain cleanup code runs regardless of what happens in the try or catch blocks. The finally block in Java is used in conjunction with try-catch blocks to ensure that certain code is executed regardless of whether an exception is thrown or caught. This makes your code more robust and reliable. Section 4. Ensuring a graceful exit, the finally block. By using the finally block, you can make sure that your application exits gracefully, releasing all resources and performing necessary cleanup tasks. Section 5. Crafting order from chaos, custom exceptions. In this section, we will delve into the importance and implementation of custom exceptions in Java programming.
While Java provides a comprehensive set of built-in exceptions, there are situations where you might need to create your own custom exceptions. These custom exceptions can help you handle specific error conditions that are unique to your application.
Custom exceptions allow you to define specific error conditions that are relevant to your application. This makes your code more readable and easier to maintain, as it clearly indicates what kind of errors can occur and how they should be handled.
For instance, class invalid input exception extends exception, public invalid input exception, string message, super message. This simple example shows how you can create a custom exception that provides a specific error message when invalid input is encountered.
This code defines a custom exception class called invalidInputException, which extends the built-in exception class. By doing this, you can create more meaningful and context-specific error messages.
You can then throw this custom exception in your code when you encounter invalid input. This helps in pinpointing the exact issue and makes debugging much easier.
Custom exceptions help you make your error handling more specific and informative. They provide a way to create a more robust and user-friendly application by clearly defining what went wrong and why.